In this problem, a person is about to pour his hot coffee into an aluminum cup. When he does that, his cup is going to warm up. His coffee is going to cool off slightly. What is the final equilibrium temperature of now the cup and the coffee together? And so what's happening here is that there's heat being gained by the aluminum cup. Well, that's got to be equivalent to the heat that's being lost by the coffee itself. And when you take all that into consideration, that heat is an object's mass times its specific heat times its change in temperature. So again, what's being gained by the cup is what's lost by the coffee itself. And when you rearrange to solve for the final temperature that these two things now have in common, it's the mass of, let's say, the aluminum times the specific heat of aluminum times its original temperature plus the mass of the coffee times its specific heat, which it tells us in the problem is the same as water, times the coffee's original temperature, and then divided by the mass of the aluminum times its specific heat plus the mass of the coffee times its specific heat. And again, you can arrive at this equation by saying that what's being gained by the aluminum is equivalent to what's being lost by the coffee. But then you had to go through the trouble of rearranging to solve for that final temperature, isolating, getting that on the side of the equation by itself. So this final temperature is the mass of our aluminum, 152 grams, times its specific heat, 900 joules per kilogram degrees Celsius. Now I notice, right here that already I have kilograms and I just wrote grams. So I'm going to convert right here and divide this by 1,000, make it 0.152. All right, I didn't catch that before I wrote it down, but I noticed kilograms here. Times the aluminum's original temperature, 20 degrees Celsius. All right, add to that the mass of the coffee, 383 grams, right, or 0.383 kilograms, times its specific heat, right, 4186 joules per kilogram degree Celsius, times the initial temperature of the coffee, 75 degrees Celsius. All of that divided by the same values without the temperature, the 0.152 kilograms times 900 joules per kilogram degree Celsius plus the 0.383 kilograms times the 4186 joules per kilogram degree Celsius. And so unit-wise, before I punch this in my calculator, we're going to have kilograms down here in the bottom in the denominator to cancel the kilograms in the numerator. We're going to have right here joules per kilogram degree Celsius to cancel those joules per kilogram degree Celsius. And then at the very end, we got Celsius plus Celsius. And so 0.152 times 900 plus 20, times 20, I'll get it right, okay, plus 0.383 times 4186 times 75. I'm going to go ahead and take that value for my numerator, and I want to divide that now by 0.152 times 900 plus 0.383 times 4186. And so we get a final temperature of 70.7 degrees Celsius. So this coffee cools down just a few degrees. The aluminum itself warms up by just a little over 50 degrees.